the theme of my talk for today is really to first of all build upon the work of the conference, Principles to Action. And then I'm going to share with you a little bit about the work that I've done and a little bit about my philosophy about how we can really engage students in mathematics through pop culture and the popularization of mathematics and some of the work that I've done through the Chelmsford Public Schools. And as Mia talked a little bit about, through this television show, music videos that I do with teachers and kids called Math with Matthew. So as a review in regards to Principles to Action, we have the guiding principles for school mathematics. That's detailed in the book, and Linda talked about that this morning. Where I want to focus the majority of my talk with you today is on the teaching and the learning. That's going to be the focus, is that's how we can ultimately improve student learning. And that's ultimately what we want as teachers, and for those of us that are math supervisors, that's what we want our teachers to be focusing on, is improving student learning of the mathematical concepts. So the focus of my talk is going to be on that teaching and learning. Now, over my time as a teacher, as an administrator, as a graduate instructor, I always try to focus on how can we improve student learning in mathematics, because it's not easy. So before I share with you what I believe are the 4 most important factors that I have found about what teacher knowledge is necessary to improve student learning, which is our ultimate goal, what I'd like to ask you to do is take 2 minutes at your table and have a quick discussion with your table and think about what factors, what teacher knowledge, what important skills do teachers need to have in order for their students to learn math. So 2 minutes, talk at your table for me. Okay, if we come back together. Any volunteers? Any volunteers want to share about one idea, one teacher knowledge, one skill that a teacher needs to have in order to be successful to improve student learning? Any volunteers? Yes?
Flexibility.
Flexibility? Okay. What else? What other skills? What other knowledge does teachers need to have? Yes, thank you.
Not necessarily knowledge, but the passion for the subject.
Passion for the subject. Excellent. What else? Yes?
A deep understanding, conceptual understanding of the actual concept itself.
Knowledge of the actual subject. Excellent. Yes? Okay. Content knowledge about what they learned previously and what comes next. Great. Yes, thank you.
Empathy.
Empathy for the kids, for the subject, for
Everything.
everything. Okay. Just empathy in all grades. Right. Yes?
Ability to bridge the gap between the way they were taught and the parents were taught and the way the kids are being taught.
Okay, so some pedagogical knowledge is important. Right? A couple more?
Knowledge about how children learn.
How children learn. Great. Sense of humor. Absolutely. Okay, so I'm going to share with you, and a lot of these ideas are embedded in my ideas because we're kind of all on the same page, being at the same conference together. But before we do that, I need to admit something to you. If I could come back in another life, I would be a game show host. For those of you that eventually make it onto my website, you'll see that within the Chelmsford schools, we inform the parents about the new park assessment through some game shows. It's quite interesting. I get to play a game show host, which I really love. And so what I'm going to do is, in the theme of Family Feud, does everybody know the show Family Feud? So I'm going to share with you the top 4 answers on the board. And if you know how the audience reacts when it's Family Feud, you know what you do? Everybody says it together. And we go through it together, Family Feud. So let's take a look at the top 4 answers on the board, according to at least Matthew, as to what teacher knowledge is necessary to improve student learning. So let's take a look. Number 4, show me. Assessment. That was very impressive. Didn't you do anything? You clearly like the game shows as much as I do. Number 3.
Relationships, classroom management.
You know, I thought about cutting out the classroom management because people wouldn't know if they should say the whole thing or not, but you did an excellent job. So, as a participating group, I have to tell you, you guys are killing it. Okay, number 2.
Pedagogical knowledge.
Very Very good. And the number one answer is?
Content knowledge.
Excellent. So to me, in my role, and what I have done as a teacher, as administrator, as a coach, as an instructor, these are the 4 areas. And these 4 areas are really interconnected as a way to improve student learning. And I want to talk a little bit about each of these 4, somewhat to how it's connected to principles to action, and somewhat how it's connected to my work that I have done working with teachers and as a teacher myself. So the first thing has to do with the content knowledge. And this is something that I heard someone say in the beginning here, is that you need to know your content as a math teacher. Not only for the grade level in which you're teaching, but you need to know what comes after it. It's not good enough if I'm an 8th grade teacher and say, listen, I know how to teach Algebra 1. I have Algebra 1 skills, but I don't know anything about Algebra 2. I don't know what comes after that. That is not enough. We as math teachers, as math leaders, need to make sure our teachers know the content, what they're teaching, and the content of where it goes next. That is very important. And it's important for teachers to know about mathematics at all the levels. We spend the majority of our time on the high school math and the middle school math, but it's just as important at the elementary. And in order to really show how important this is, I am going to go out on a limb and ask for 2 volunteers to come up with me here and play a little game. Any volunteers? I need 2 volunteers. I will tell you there is a prize, not just for the winner, but for both the winner. Okay, we have one right here. Yes, come on up. Come on up. This is going to be good. So we are going to do the $64,000 question here as we try to learn a little bit about how much math content and pedagogical knowledge our teachers have at the different levels. So why don't you ladies face the stage, you can introduce yourself. This is
Emily.
Emily, thank you so much for coming here today. Having a good time?
Yes.
This is the talk show host game show. And who do we have here?
Nancy.
Nancy, very nice. Where do you come from, Nancy?
Lancaster.
Lancaster, excellent. I come from Bolton myself.
Oh, yeah.
Yes, great school system, very nice. Okay, so if you wouldn't mind holding this here. So we're going to put them on the spot a little bit. We're going to play the $64,000 question. And the question is, I would like to find out what % of our teachers at each of the different levels have a degree, not necessarily just in math, but either math or math education. So we're going to start off by asking Emily, and then Nancy's job is to predict if it's going to be higher or lower. Okay, we're going to play best 2 out of 3 here. All right, so Emily, high school teachers, according to a national average, not necessarily Massachusetts, what % of our high school math teachers have a degree either in math or math education?
75%.
75%. Nancy, you want to go above or below?
Higher.
She says higher. Let's take a look. High school level, 73%. Very good guess. Emily gets the first point. So now we're going to switch. Nancy's going to go first. So if you give the microphone to Nancy, let's do middle school teachers. What % of our middle school teachers, 5 to 8 we'll call it, have a degree in math or in math education? What's your percentage? What do you think?
50%.
50%. Okay. Higher or lower?
Lower.
Lower. Let's take a look at our middle school. 35%. I mean, technically, we actually don't even have to continue because Emily already won. But really, this is not about the game show. This is really about the learning, what I'm trying to do. So we're going to do the last one, okay? So we'll come back to Emily. Emily, what percentage of our elementary teachers have a degree in math or math education?
5%.
5%. Nancy, above or below? Less. Let's take a look. That was the most vocal one. Maybe that should give her 2 points. Let's take a look. Less is correct. 4%. Thank you so much for playing. Round of applause for Emily and Nancy. Let's take a few moments and actually digest this information and find out what we can do with this here. So it's clear. We're all math here. We're all math people here. The lower the grade level, the less likely it is that the teacher will have a math or a math education degree. The real focus is on the elementary teachers. Now, they have the most difficult job possible. I could never be an elementary teacher. Honest to God. They have to know reading, writing, math, science, specials. It's very difficult. And the vast majority of them go to school for reading and writing. And I'm not going to say that reading and writing is not important. It's very important. But oftentimes, for about 96% of them, math is not their focus. And these are the teachers that are teaching our kids the foundation of the math knowledge that they're going to use in middle and high school. So it's our job as math supervisors, leaders, coaches, whatever frame of reference you come here today, to make sure that your teachers, elementary in particular, get the appropriate content knowledge that they need. That is very important, and the middle school and high school teachers will thank you for that, because they don't know the content. As a former K-8 math coach, I can tell you there's nothing wrong with this. You know, they're great teachers, but the vast majority of them can't pass an 8th grade Algebra 1 test. They just don't know it. We need to give them the content. And with the middle school teachers, the way the certification is in Massachusetts, you can be a K-5 or K-6 generalist, and you can teach math or math science without ever actually having a degree in math or in math education. So us as leaders, we need to focus our time and attention on the content, especially for our K-6 teachers.
Is that true in Massachusetts?
That is Massachusetts. Yes, the vast majority of our teachers in Massachusetts are K-6 certified, so they could be a 2nd grade teacher, 1st grade teacher. They could go and teach 5th grade math or 5th grade math science or English language arts. They're a generalist, and a lot of them like to move around the grade levels. Having said that, if they're teaching math, we need to support them with the content. Okay? So back to the list here. In addition to our elementary teachers, and for some part our middle school teachers, there's 2 subgroups of teachers who are often not given the attention that they desperately need with the content. And those are our specialists. Our special education teachers and our L teachers. Our special education kids are our neediest kids and the most important kids that we need to focus on. And for many of these kids, the direct instruction that they get are from their special education teachers. And they have special education degrees, and they do a great job with differentiation and modification. But they themselves often don't know the math content. So when we often offer PD for our middle school teachers, or sometimes even our high school teachers, these teachers are left out. And they are the ones that need the professional development. So I encourage you as a math leader to make sure you focus on these types of teachers as well. And then something that I think is very important, because I teach a course on the history of math, is that if there's one course that you should take, if you haven't already, or your teacher should take, is a course on the history and development of math. Both from a standpoint of engagement, but also the way concepts of math have been developed over time. It is really remarkable, and I'm going to share with you one of my favorite stories. Everybody knows Pythagoras, right? You know, he's got his theorem, and he's got his group of followers. They're called the Pythagoreans, and they're a very quiet, secretive group, and they do math in their own special way. And they only believe in rational numbers. Okay? That's Pythagoras' rule. And so one day, one of his followers came to him and said, his name is Hippasus, and he said, "Hey, Pythagoras, you're not going to believe this. Look at this. I found out that there's an irrational number." Pythagoras says, "Oh, no. No, there's not. We only believe in rational numbers." "No, Pythagoras, really, this is correct. Look at this. I have a proof, too. This is unbelievable." "No, I'm sorry. We only believe in rational numbers. Never speak of this again." And so Hippasus is saying, "Oh my gosh, what do I do here? I found out this great math thing. What am I doing? No one's listening to me." So he actually went outside of the Pythagorean group, and he shared his mathematical knowledge. People were like, "Wow, this is great." And Pythagoras found out about it. He took him on a boat. And he threw him overboard. Bye-bye. But the story doesn't end there. Because a couple years later, Pythagoras is looking at Hippasus' work, and he's like, "Son of a gun, that guy was correct." And to this day, do you know who's credited with irrational numbers? Pythagoras. So stories like that don't necessarily have to do with the math content, but it's a way to get the kids connected to the content in a way that oftentimes we do not see in our math classrooms. And the last thing related to the content has to do with the application to the real world. We all get this question all the time. When am I ever going to use this? And one of the best responses I've ever heard has to do with, and this is a self-promotion, I'm so sorry, has to do on my Math with Matthew website. I did a podcast with a Harvard professor, Dr. Starr, who gave a great answer when I asked him about this. And he said, sometimes you're just not going to apply it to the real world. Some math, it's just not going to happen. Sometimes in English, you read a book, Hamlet, and you can't apply Hamlet to the real world. It's just the beauty of it. But, much of the time, math can be applied to the real world. Math can be shown about when you would use it in your daily life or in a future career and profession. And as math teachers, as math leaders, we need to make sure that this is brought up in our classrooms, okay? For many reasons, our classes are often stagnant and they don't have any real application. It is, here's how you do the problem. I'm going to do it for you. Now you do it 10 times. And you know what you're going to do for homework? Do it 20 more times. I don't know, what am I, a robot here? What am I doing? What am I doing? So, when applicable and appropriate, we have to make sure that we tie it to the real world. Moving to pedagogy. As we saw in Principles to Action, it is very important that we focus on conceptual understanding and procedural fluency. Both are very important in math instruction. And with both procedural fluency as well as conceptual understanding, we need to make sure that our teachers are teaching for understanding, not just for memorization. It's not so they can just take this test in 3 days and never remember it. So whenever we give something like the formula for area of a circle is pi times radius squared, we need to make sure our teachers and we show them, why is that the formula for area of a circle, pi times radius squared? Why is that? How can we show that? How can we prove it? Well, it can be actually proved in a very elementary way that a 7th or 8th grade student could understand. It's not just, here's the formula, memorize it and use it. We have to teach for understanding. We also, as teachers in our classroom, have to make sure that people are solving problems multiple ways. It should not be that I'm the teacher and I'm showing you how to solve this problem one way, and now every single person in this class has to solve it the exact same way. When I was a teacher myself, and I do miss teaching, when I was a teacher myself, I prided myself that you give me any math concept, and I can teach at least 3 different ways for the different learning styles. We have to make sure that our teachers know the content, as well as the pedagogy, to be able to teach things multiple ways. And also, many of our students like to come up with their own creative ways to solve problems. We have to make sure that in our classrooms that this is not only encouraged, but we are able to show this work in the class. As long as it's mathematically sound, if we have a discussion on a single problem that's solved 5 different ways by 5 different kids who can show the work and explain it, that is how you build conceptual understanding in a classroom. It's not by me showing you the one way and you do that same one way, and if you have your own way, say, no thank you, I don't understand that way, we need to make sure we do it my way. No, we want to build conceptual understanding by knowing how to and encouraging students to solve problems multiple ways. Next, I want to talk about lesson planning. This is kind of a taboo word where, as a graduate instructor myself, we spend time creating these lesson plans that are 4, 5, 6 pages. It takes 2 hours to do the lesson plans, and then they actually get in the classroom and they never write a lesson plan again. So there's this disconnect. That's a talk for another day. However, what I want to share with you today, what I believe, based on research and my own experiences, are the 3 most critical parts of a lesson that you should be encouraging your teachers to focus on, and you should be looking for these things when you're actually in the classroom. The first has to do with objectives. We cannot have teachers doing activity-based lessons. There has to be an objective, a goal, a purpose. Why are we doing what we are doing? These objectives should be posted, optionally referred to at the outset of the lesson. That is critical. That does not take hours to do. That might take a couple of minutes to do. But it's something that really the research says really strengthens a lesson. The second thing, and I'm going to talk more about the second thing, assessments, that's a big dog I want to focus on, but there should be frequent formative checks within a lesson. I'm not talking about a 30-minute paper and pencil quiz. I'm talking about we should be seeing quick checks to make sure whatever it is we want to focus on, whatever it is we want to learn, they're learning it. And if they're not learning it, we want to know so we can beep, beep, back up, slow down, figure out what's going on, have that conversation on the prior knowledge. So there should be these frequent formative assessment checks. And then the last thing is a summary phase of a lesson. Lessons should not be ending just because the bell rang. Oh my gosh, it's the bell, everyone leave, we'll see you tomorrow. No matter what, lessons can take 2 days or 3 days, and over lunch I was just talking with Linda about this. The best lessons often take multiple days, but there needs to be a summary phase in the last 5 to 7 minutes of every lesson where you bring them back together, you check for their understanding, you preview the homework. Let's all look at question 1 together right now. By the way, if you do that, it's much more likely they'll actually do the homework if they see it in class and you talk about it, as opposed to the first time they open it up is when they're at home. So you have that check-in, you look at the homework together, you find out if there are any questions, and then you preview what we're going to do the next day. Research, as well as my practical experience, supports this idea of a summary phase of each lesson. So, a debate for another day, the actual full lesson plannings. But if you can focus your teacher's time on objective-based lessons, formative assessments throughout, and a summary phase of a lesson, you will strongly be increasing the learning that will take place. Next has to do with authentic experiences. Much of what is presented in the textbooks outside of McGraw-Hill does not offer students with real, authentic experiences. Some of the problems that we see in these textbooks have nothing that they can relate to. They really don't even make sense oftentimes. We need to take it into our control to modify our lessons and give them experiences. And I'll talk a little about that when I talk my second half on the pop culture. But experiences that ring true to them. It's the Monday after a Patriots game. Let's take a look at some of the yardage that was created. How did they do on this drive, gaining yardage here, and use that for integers, adding and subtracting integers? Or finding something that they relate to in regards to music, sports, movies, technology, something that really rings true to them. Because the way they learn outside of school with the technology, the iPad, the iPod, the i-this, the i-that, is often not translated into the classroom. Standing up with the board, this is how you do it. Oh, you don't understand it? Let me say it louder. Now you need to multiply by 3x to both sides. What am I even doing? So encourage your teachers to have authentic experiences. Moving on to relationships. Relationships I really break down into 2 categories. The classroom management, and then the building relationships with all stakeholders within the school. Now, the reason I really bring up classroom management is that you could know your content at the PhD level. You could know the pedagogy at the EdD level. But if you don't know how to organize and run a classroom, nothing will be accomplished. Our teachers need to make sure that they have, I don't want to call it, strict rules, I'll yell at you when you sit down, but we need to make sure that they know how to organize a classroom, run a classroom, understand time elements of it. If situations arise, how do you diffuse it in an orderly manner so it does not disrupt the class? One of the things that we started doing in the Chelmsford Public Schools is that anytime we are hiring new candidates for any position, we ask them to do a sample teaching lesson. And it's a bit contrived, it's somewhat difficult, but you really get a sense of how they present themselves to the students. Do they try to form relationships with the kids? Ask them their names, relate to them. Because those teachers that do that, they're much more likely to be successful. But it's not just the relationship with the students that's important. It's the relationships with all the stakeholders within the school and the school system. Now, the last one on my list is a little bit interesting. It's like, well, okay, parents make sense, okay, administrators make sense, and then secretaries and custodians. I'm going to tell you a funny story from my first year teaching. I'm a first year, and I'm a little awkward. I got to carry a whistle for some reason because I was coaching, and I had a briefcase and wore glasses. But that's not really the point of my story here. But my mentor, she was the social studies teacher, and around Christmas time, she would bring people gifts. And I noticed that she gave the secretary in the main office a gift as well as the custodians. So part of our mentoring session, I asked her, I said, Betty, that secretary, she's so mean. Why are you giving her a gift? She said, she's not mean to me. She takes care of me. I have a relationship with her. Have you talked with her at all? I said, no. There's your problem. And the custodian, same idea. I said, my room hasn't been cleaned the whole year. Have you seen my room? My room's always clean. I take care of my custodian. I say hello to him. I ask him how he's doing. Do you know the names of his kids? He has kids? Yeah. Take the time to have relationships. So as we have new teachers in our buildings, math teachers in particular, but any teachers in our buildings, as mentors, as math leaders, as supervisors, we need to make sure that they form and develop relationships with all the stakeholders that they interact with on a daily basis. And then the last thing has to do with assessments, okay? Now I'm on this Facebook group. I like Facebook. It's fun. But I'm on this Facebook group that has to do with math education researchers. It's kind of some of the professor-y type and some of the teachers type. And just last week on this, someone made a post about how assessments is one of the most overrated things for administrators that really doesn't apply to teachers. And so I immediately started my two-finger typing, and then I realized what my wife always says to me: take a few hours, don't respond right away, you'll overreact, and even in a Facebook thing, I'll overreact. And I just thought about it a little bit, and I read some of their threads. And I guess a lot of the concern is how much we're testing the kids these days, especially in Massachusetts. You've got the MCAS now live at the park, the district determined measures with the evaluation tool, and there is a lot of testing that goes on. My thoughts on assessments are these, is that first of all, assessments are only good if you analyze them and help guide your instruction. The idea of assessments is really supposed to be a process where you don't just assess for the purpose of giving a grade, okay? You should assess to do analysis of how the kids are doing. What are they learning? Is there any particular students that aren't doing well? Are there any concepts that 80% of the class is not learning that we need to revisit? And then the analysis should come back and guide us to our actual instruction. And something that I am a big proponent of is to have these data meetings where we actually talk about student work, look at student work, look at data together, look at common assessments. It's not my job, I'm not a high enough role here to make decisions about state level things, about MCAS and PARC and what we're doing, but if we are doing it and they're telling us we have to do it, fine. Let's make the best we can out of it by analyzing it and talking about the data. That, to me, is very important. And you don't have to be every Friday giving a quiz, no matter what. It doesn't matter, we just started a new lesson this week, but Friday's quiz day. We should not be doing that. We don't want to be over-assessing them in that sense. Some of our quizzes can be very short, 5 or 10 minutes, because we do need to get grades. Grading is part of it. But use the assessments for a real purpose, okay? So it can help improve student learning and can guide your instruction. So these ideas I have incorporated through my own teaching and through the teaching of the teachers that I work with within the Chelmsford Public Schools. And within the Chelmsford Public Schools, where I'm the math coordinator, the teachers are excellent, and our state scores are excellent as well. They've gone up. And I'm not saying this to brag, there's a purpose here. They've gone up to the highest they've ever been. But here's something that I've found, not just within my school system, but through many of the schools that I visit. There is still a lack of interest and engagement in math. Yes, we're required to take math. We have to. If you want to graduate now from math school, you need 4 years of math. So you don't have a choice. We need to take math. But many of our students are not genuinely interested and engaged in math. And so a couple of years ago, when I became the coordinator of the Chelmsford Public Schools, through a variety of different groups, through my administration and through the town Chelmsford Telemedia, I decided to make my own TV show as a way to inform the public, inform the community about the great things that we're doing in the schools and the great things that teachers are doing in the schools, and also find a way to increase their level of interest in mathematics. And so I'm going to show you a clip of some of these music videos that have been created by myself, some of the math teachers, and a lot of the kids within the district. And it all started off, as you can see, I'm wearing a Beatles tie today, where I started with a little spoof on All You Need Is Love. We made it All You Need Is Math, and it grew into something that I really enjoyed. I'm going to share that with you, and I'm going to talk a little bit about what we have done. So, in conclusion, it is clear that throughout all of school and life, all you need is math. So, in conclusion, all you need is math.
All is all you need.
All you need is math.
Everybody now.
All you need is math.
Sing along at home.
And now this is What Does the Fox Say? As we explore the value of time.
Plus means addition, minus means subtract, x means multiply, and slash means divide. M is the slope, y is a variable, and the b is the intercept. U is for union, f is for function, and the quartiles label q. But there's one value that no one knows. What is the value of pi?
3.1415926535897932384.
And you know the Lego movie, Everything is Awesome? This is Polygons Are Awesome.
Polygons are cool when you have straight sides. Polygons are awesome when they're drawn nice and wide. Shapes are always better when they're stuck together. Side by side, you and I will examine, learn, be regular forever. We're the same.
And this is from Gangnam Style. Get a little bit hard.
Help you comprehend.
Sine is opposite over hypotenuse. It's a ratio of the sides. Cosine's adjacent over hypotenuse. It's a ratio of the sides. Tangent's opposite over adjacent. It's also a ratio of the sides. Sokotoa style.
Sokotoa style.
And then the last one, Taylor Swift. This is Science and Math. We're on the Math and Science coordination.
Pad, iPhone, Android, and PC. Without mathematics, none of these could be. Every tweet, every snap, and every single rhyme. Mathematics is the language upon which you rely.
Mathematics! What you're talking about? That's computer science without a doubt. You might be the language, but you need us to speak it. Think about that before you tweet it.
Evolution, distribution, pick your side. It's a science and math war. Time to settle the score.
I'm going to show another video in a few minutes about some elementary kids that have given me a sales pitch for some new songs that I should be doing. That's really, and I'll show that at the end. It's really, really cute and adorable, and that's the next project that I'm going to work on. So I've been doing these videos, and I've been encouraging teachers to kind of focus on pop culture within their math instruction as a way to engage the kids. And I wanted to find out, does this actually work? What impact does this have? So I conducted a research study for a paper that I wrote for a conference, and there were two questions that I really wanted to look at. I wanted to find out about what impact pop culture references has on their interest and engagement in learning math, and I wanted to somewhat selfishly find out about my Math with Matthew videos, these music videos that I do. Do they actually increase the students' level of interest in learning mathematics? We know, for the most part, we have that knowledge, they're learning it, but are they actually now becoming engaged and interested in it based on these here? So what I did was I conducted a survey of students who had been involved, seeing these videos, been involved with it one way or another, and I got some information on them based on their grade level at the high school, what math course they take, how much they enjoy math, if pop culture references are occurring within their school, within their math classes, how much interest they have on it, and then what do you think of these Math with Matthew videos? And I got some very interesting results, and it's very preliminary, but here are the results. The first question I said was, how often is pop culture references occurring within your classroom? And it's not really that surprising that only 6% of it isn't occurring most of the time. Although 40% of the time, there's some references to this. Just so I could get a baseline as to how often it's occurring. But what was more interesting to me was that when I asked the students the question is that if we had more pop cultural references, more references to music and movies and sports and things that you're interested in, if that was infused into your classroom through instruction or through problem sets would that increase your level of interest in mathematics? Quite a few people were not sure about that, and I attribute that to the fact that they're just not familiar with it because it doesn't occur. But only 12% of our students said they did not want pop culture into their math classroom. So about 1 in 8 said, I don't think that would increase my interest. Doesn't necessarily mean that 7 out of 8 will, but it means that if we want to increase their interest in math, their engagement in mathematics, this is something that's worth exploring. And there was 2 relationships that I found that had very strong correlations, and they both are very interesting to me. The first is that there's a direct relationship with the level, the math level that they take. And we have basically 3 to 4 levels at the high school, and how often pop cultural references are occurring. I found that almost there's no reference in the honors or the AP classes. It's very by the book, here we go. But the lower the level you go, for those struggling kids, the lower level classes below the college prep, there's quite a bit of that. And I had, the data sample that I had was too small to make any sort of conclusions, but those students who were in that lower level were actually reporting they enjoyed math more than those that were in the honors level. And that actually blew my mind. I assumed the kids that were in the honors level were the ones that loved the math. Might not necessarily be true. Those kids that struggle, if they're being able to be engaged, they actually really enjoy math. And the second thing is that students that are taking math classes that have this popular culture infused into this are more likely to enjoy their math class. A direct correlation at the 0.05 level, those kids that are happy with their math class also are more likely to have the pop cultural references in the class. And then I also wanted to find out a little bit about the math with Matthew, and I found out that there was only one student out of my sample who had seen the videos here who said that having that in the class would not increase my level of enjoyment of mathematics. 12 students were unsure, but the vast majority said, if I could see these videos, or I could even participate in these videos, or maybe I could help write a song for this, or be involved in this, it would make me interested in the math that I'm learning. So now I'm starting to branch out a little bit to really incorporate different students' ideas as we make another 2 or 3 math music videos this year. And as I talked about in the beginning, is that the best thing that I've gotten is some videos from parents where their kids, either during recess or free time or playtime, are actually trying to write their own Math with Matthew videos. So take a look at a couple of these videos that got sent to me by parents.
Oh, I think that I found myself a math teacher. He is always right there when I need him. He teaches me to add and subtract and some long division. This is how you subtract 7 from 12. First you write 12, then below you write 7. Then you subtract 7 from 2, but wait, you can't do that, so this is what you do.
So those kids are very cute. And what I'm actually working on now, and this is a few of my math and science teachers who are dressed up like Pythagoreans, is that I'm working on a pilot right now for WGBH, is possibly the pilot this fall, of Math with Matthew, that's set up like Bill Nye the Science Guy. Remember that show from the 90s? I'm trying to do that for math, where we take one math concept. In this case, the pilot here is on the Pythagorean theorem, and we spend a full 30-minute episode learning about it in a fun and engaging manner through music, through pop culture, through interesting stories of the history and development of math. And this is something that I'm trying to pursue myself, and I've already created an episode, and I'm trying to create a few more of these here, just as a way to help kids become interested in math like the way they are in science and some of their other subjects. So, a lot of different things that I spoke about here, and I wanted to share with you a few takeaways. The first and the most important one has to do with principles to action. And I know that Linda spent a lot of time with you in this morning on this book. And every few years, NCTM comes out with a new book based upon the research that they have conducted, written by many different researchers, authors, practitioners, and it really is the guiding focus of mathematics education. I strongly encourage you not only to read this book yourself, but to purchase this book for your teachers and maybe hold a study group for them. Have a book group about this, like the way we have a book group for English language arts. The ideas in this book can really help improve student learning. The second takeaway, and this might be more important, has to do with McGraw-Hill. Because I have to tell you, I am done going to these state-sponsored conferences at the Motel 6, where I have to pay for everything, $15 for a box lunch here, and I'm worried about what the heck might fall down on me. This is beautiful, so thank you to everyone from McGraw-Hill that organized it. I mean, I can't even understand how you're even looking at me when you have the view of the ocean here. I mean, I'm just distracting myself looking at this. And back to another few points here is that we as math leaders, as math educators, need to increase the student interest and engagement in mathematics. We want them to learn conceptually, absolutely, that's priority number one. But we also want to spend some time increasing their level of interest in mathematics. We can do this through popular culture references, as I spoke about in some of my researches on. We can also do that by trying to tie it to the real world or giving them real world application for the mathematics. And we can also do this through some of the history and development of mathematical concepts that can be done through coursework, through videos, through engaging activities, so they can see how a concept was first developed and how it was refined over the years, and how math was built over time, from the Babylonians to the Egyptians to the Greeks, all the way up through modern mathematics. So, I thank you so much for your time. Enjoy the rest of the conference. Thanks for having me today.